Hi everyone, welcome to the third of our HPC Perspectives Live. My name is Sharon Howe and I'm your host today. Previously in these discussions, we've got to know Agnès Boudot and Laurent Clerc, and both of those chats are still available from our website and on YouTube. As promised, we'll continue to host some discussions and introduce you to a number of different people across our group who will bring their own insights into the different aspects of our HPC and cloud solutions business here at CGG. Our guests will share about who they are, their roles and activities, so you get to know some of the teams and technologies that make our HPC happen. Today, I've got the great pleasure of having two of my colleagues join us. Once again, we're very international. I'm pleased to welcome Anil Vattalai, who is VP of our HPC Platform Development and Business IT. Anil is based out of Houston in the US. And also joining us, we've got Florent Pautre, who is a computational science architect based in France. So thank you both for joining me today.
Thank you, Sharon.
Great. So, Anil, let's start with yourself. What does a VP of platform do?
Yeah, so we have a team of very talented and passionate software developers who are working on platform development as well as business systems solutions. Um, for the platform, or what we call platform, is basically a software or layer of software that comes between the hardware, the HPC resources that we have, and the application software. So we provide a bunch of libraries and databases and tools that the application developers can use that hides in a way the complexities of high performance computing systems, which involves compute, storage, networking, and so on. So by doing so, it allows the application developers to focus on what they do best. It can be the algorithms or features for the end users, which is really like the business applications, and optimize the use of HPC resources in a way that is good for individual applications, but at the same time coherent with many other potential applications that are running at the same time in our HPC systems.
And I know we'll come and talk a bit about that optimization in a short while. But what does a typical day look like for you?
Well, we are very fortunate to be in a very specific position where we get to work with our hardware, the HPC resources, and the people who are working on the IT side, but at the same time with the end users and the applications. So every day we will be working on providing features and solutions for adding new features or optimizing the existing applications overall to improve the user experience, at the same time improve our HPC resource usage optimization as well.
Great, thank you. And now, Florent, thanks again for joining us. How long have you been with CGG? And maybe you could tell me a little bit more about what a computational science architect is.
Hi, Sharon. Thank you for the invitation. So I started my career within CGG in 2012, and I joined the IT strategy in 2015. So what is a computational scientist? We have two missions. We are first in charge of the technology scouting for everything related to computation, so CPUs, GPUs, servers, and so on. And then our second mission is to qualify the hardware within the CGG ecosystem, and finally to optimize the software and the configuration based on our hardware knowledges. So I've been involved in various projects from FWI kernel optimization to benchmarks of exotic accelerators.
Great, sounds. We'll come on to some of those in a minute. So you both work in that area really between the hardware and the user application. Coming back to
Yeah.
that optimization piece, Anil, why is optimization such a key topic for CGG?
Yeah, optimization is extremely important for CGG. CGG operates in an extreme end of high performance computing, mainly for scientific workflows. So these are workflows that are normally very complicated or complex, and they access vast volumes of data, and they use enormous amount of compute capacity, right? Our geoscience team, for example, they are the technology leader by far in the seismic imaging industry, and they always, push the envelope of their HPC resource utilization. They have more and bigger projects each time. The data sets are getting bigger, the algorithms are getting complicated. So to support these kind of clients that um, we have close to 400 petaflops of compute capacity, which is supported by more than 250 petabytes of storage. And it is important for us to keep our usage level very high, and we keep our compute usage up to 95% and above of our capacity all the time.
That sounds like a huge task.
It is indeed, and at this scale, right? So, at this scale, in fact, it is really important for us to make sure our resources are efficiently and effectively utilized and the cost is well managed. So, to do that, optimization is critical for us, right? And for us, optimization is not a task that is one time or a point in time, neither it bound to particular limits. It's a continuous activity.
With all of that going on, I mean, that's a huge scope to look at. What are those different areas that you can optimize?
Well, we look at all aspects of the application, from the algorithm all the way to the resource usage, to the data storage, the data access, to the type of hardware and the configuration of them, right? The ability to optimize the applications top to bottom at all levels allow us to get the best use of our HPC resources, and at the same time allow our users to keep pushing the boundaries of their technologies, whatever it is, right? So we optimize applications for performance, we optimize for efficient use of compute, storage, or even power usage, which is an important topic these days, right? And we have also option to scale vertically or horizontally or a mix of both.
And I guess, with the scale of resources that we manage and the size of the jobs, that small improvements everywhere can have a really significant overall impact.
Correct.
Yeah. Florent, maybe tell us a little bit more about the specifics of how we go about that.
Sure. So, from my perspective as a pure computational scientist, 7 or 8 kernels could represent more than 50% of the total cycles spent for the migration, which are one of the most expensive jobs in the geoscience industry. So the importance of optimizing those kernels has not to be demonstrated. However, as Anil mentioned, we will seek the bottlenecks on the full workflow. For example, if the storage is too slow, it's not worth it to keep on optimizing the kernels. So the global coherency of the environment is a key factor. You can't put a Ferrari motor on a Ford Focus, with all due respect to that car. So I would add that energy optimization becomes, as Anil mentioned, extremely important because an increasing number of data centers are power capped, and the price of electricity has risen significantly recently.
Yeah. And maybe thinking about that, can you elaborate some more about those trends that we're seeing and perhaps some of the impacts that's therefore having on sustainability and power usage?
Yes, so the requirements for HPC data centers are evolving rapidly. In the past, the focus was on achieving higher compute power and density at the rack level. However, the latest components roadmaps indicate that a significant increase in peak power and TDP for current and upcoming generation of components. So this change is due to the disruption of Dennard scaling law, which has led to the development of energy-intensive hardware, resulting in new challenges for data centers. These challenges include the cooling of high-density systems and maximizing throughput in power-capped environments. So, with this power capping challenge and energy price rises means that highly optimized and tuned codes from the HPC community are needed to balance performance and energy consumption.
Yeah, I can see that this then becomes a kind of quite an important topic for sustainability, being able to get the same outcomes for that overall, less energy usage. So, yeah.
Yes, yes, indeed. If we can get the same output, the same outcomes for less overall energy usage, that's obviously a really good thing.
Great. Anil, how do we go about identifying those bottlenecks or understanding when something isn't optimized?
Sure. I guess data collection is the key. And data collection starts with a good understanding about the application. So on one hand, we have, with the tools that we have to collect the resource usage, we can measure how the application is using different types of HPC resources like storage, compute, network. And on the other hand, we know the maximum we can get out of each of these HPC resources. So that two pieces of information gives us an entry level insight to the application performance. So this is a good starting point. But more often, we have better visibility of the applications, what they are trying to do, and what their performance objectives are, right? And that puts us in a better position to look at different resource needs and provide even a better architecture for the application based on the bottlenecks that we can observe. So to give an example, Florent in fact alluded to that. So if a compute intensive application requires to read a large volume of data, its CPUs and GPUs may become idle during that IO process, or even if that IO process is slower. So when you know more about this application, then you can look at different options. Say, for example, can you prefetch the data? Can you use a faster cache? Or even parallelize some of the activities to avoid CPU or GPU starvation. So these are options that we have when we know more about the applications. So working together with developers and users, the end users, we try to establish optimization targets or objectives. And then we work together collectively to figure out how to achieve them.
And this is then this co-design piece, what you call
Correct.
co-design. Yeah. Florent, what about your team?
So at a server scale, we will find the bottlenecks. So we did the compute, the memory bandwidth, the memory side, the network, latency, and so on. Then we will compare with the peak performances. So if a workload doesn't achieve this peak, it's not optimized. And we can extend that methodology for the design of the racks, the cooling systems, and all the different components of a data center. Comparison with the peak performance. So the limit of this methodology is the workload. You can design and optimize the system for a really specific problem, but may not be optimized or optimal for another kind of work. So if you allow me another comparison, a 4x4 and a race car have two different purposes. This also leads us to the, as you mentioned, the co-design principle. Sometimes modifying the software part to perfectly fit with the hardware parts provides a lot of gains. It implies a modification on the way we split and spread the problem, as well as the, for example, numerical scheme we are using.
And I guess the vice versa is true, that you'll identify the right hardware for the software as well. So coming back to
Yep.
that co-design
Yep.
piece.
So, exactly.
Right. You mentioned performance there. How do we measure that performance?
So it depends on what we want to measure. So we are using currently all the available tools from industry standard profilers to CGG custom low-level libraries, as well as, for example, high-frequency oscilloscope for the power or custom microcontrollers for the oil temperature. So CGG has a lot of different experts and brilliant people in many different domains. So we're trying to gather everything and to use everything available.
And then Neil, maybe some of that localized optimization.
Yeah, we have two parts. We have local optimization as well as a global optimization at the scale that we operate, because we need to make sure multiple users that we have are able to get their work done effectively and meet their time, performance, and cost goals, right? So we have to be mindful about local optimization as well as global optimization. So here, we need to have localized optimization where we can make sure each application work at their best, right? At the same time, we need to have global optimization as well. So we use standard benchmarking and profiling tools for both hardware and software to measure their performance at the local level. So we have tools to collect the data at the very basic level of each of the applications and their resource usage. And we have custom built tools for that. So when I say lowest level, we can not just the application level, but individual process level, we can measure and we can track their performance and resource usage. So these tools allow us to combine the data from multiple dimensions, and then combining all of them allow us to look at individual application performance, but at the same time, collectively the global performance as well. So we have a good view using the set of tools that we have, both the standard as well as custom tools, to get a local view as well as a full picture of the data center.
So when do we stop? I can see this being an ongoing process that could just go on forever. But how do you make that call of, enough's enough?
Yeah, that's a very good question, and this is something that we have to be very careful about, because we need to we don't there is no price for over optimization, right? We need to get it just right. So again, the core design principle that we discussed or mentioned earlier, that really comes in very handy here, right? So we have a large number of tools at our disposal, but it's very important for us to keep an eye on the cost benefit ratio. So when we work with the end users, the developers, the researchers, the IT folks, so the objectives that we set at the beginning and we agree, that will give us a good guide to figure out where we should stop.
Yeah. So I would add that for the computational scientist group, when do we stop? It really depends on the ease of reaching the peak performances. And diminishing returns sometimes just stops us due to the required amount of time. We are really focused on the perf per dollar ratio. So sometimes we have to stop.
And then I guess the overall infrastructure changes as well. So when you've got new hardware releases, do you have to start the whole process again?
Yes. So depending on the hardware, obviously, but we first have to make sure that the outputs are the same, that nothing is broken, thanks to CGG long experience on many different technologies. We often get beta version of hardware, sometimes alpha versions. So after that qualification phases, we then try to take the best of the hardware. So the technology scouting is a really important aspect of our strategy teams.
And I guess when you get new software coming in, the kind of the same happens. You're going through that process of co-design all the time.
Yeah, so
So
we don't take applications or software or hardware alone. It's a co-design principle, isn't it?
yeah. And what about when we're implementing new solutions and the choices that we've got? Because there's so much that comes out, new innovations that are coming out all of the time that I know are always really super exciting for anyone who's kind of involved in technology.
It is very exciting, isn't it? And in fact, this is where the second important components of our optimization comes in. We talked about the core design approach that we have, and the second is the component that we have that we developed over the years. So, while we are really excited about new technology, new hardware and technology, and even different software pieces, we really try to focus on technologies that can make a big difference in our applications and use cases. We don't go after every new items. We just don't have the luxury to do that, right? So CGG has been operating in the high end of HPC for several decades, right? So over the period of time, we have developed what I call, again, the second most important piece of our optimization, what I call the ecosystem of partners, right? So we keep very close connections with our partners that includes a complete spectrum of companies, from chip manufacturers to integrators to even utility providers, to have a full visibility of all our new offerings and their ability to have them deployed and maintained in a large data center like ours. So having a technology is not good enough. We have to be able to sustain it in a data center like ours, right? So we constantly review new and potential partners as well. And through this ecosystem, through these close connections and partnerships, we get to play with the new toys in the market far early than in their life cycle, and probably earlier than many of our competitors, right? Then we use our benchmarking tools, our comparison tools, and our benchmarking tools usually have a representation of our key workflows and applications that we use to analyze the performance of these new hardware solutions, or any of the new solutions, and benchmark and measure the improvements. With that data, we can make a cost benefit analysis to see whether this new hardware or new solution is really relevant in our data center for our customer base, right? And then we can make a decision and we can provide the feedback to the suppliers so that they can make changes as well. So it's really like a true win-win situation for everyone, for our clients, for ourselves, and for our suppliers. So this ecosystem is an important part that allow us to optimize and keep optimizing our systems and our applications.
And that cost benefit piece you've talked about, we're operating HPC really on an industrial scale here with for in a commercial environment. That piece is really critical, isn't it?
It is very important. So our leadership in practicing HPC at large scale for decades, and pioneering the HPC technologies is only possible due to our specific approach of this co-design as well as these ecosystems. right? That we have in place, and we nurture it over the period of time. So this allows us to collaborate with application developers, our clients, our users, our suppliers, our partners in a continuous manner. And all the time, we keep this cost benefit ratio in mind when we look at optimization and introducing new technologies. So, we were able to bring in new technologies like accelerators in computing and immersion cooling so early in the industry, in an industrial scale, right? So these are some of the examples that came up as a specific result of this approach and this partnership.
And certainly Laurent spoke quite a bit about immersion cooling in one of the previous perspectives in episode 2. Can you give an example of some of the impact this has had, some of those innovations that then maybe our geoscience teams have been impacted by?
Yeah, geoscience team is extremely important. They are the biggest users of our HPC system today, right? So I mentioned a couple of examples like immersion cooling and introduction of accelerators. Uh, More specifically, so our CGG's geoscience team is a global leader in high frequency full waveform inversion, which is a beast when it comes to compute and resource utilization, right? So a key reason why we are able to do that at the scale that we do is a close collaboration of our different teams, the research team, the software teams, and the HPC team. So the core design principle and the optimization is in our DNA that makes us fully capable to effectively address some of the scale of scientific computing that we are doing today.
Yeah, full waveform inversion is certainly one of those really critical technologies for CGG.
Yes.
What about outside of seismic, Florent? How do these skills and capabilities transfer into other industries?
So rationality and co-design are not the prerogative of geoscience. So the approach, mindset, and the ecosystem we have in CGG for application optimization is applicable regardless of the application or domain. So when we work with a new client, we may not have full access to the application or their source code. However, depending on the requirements of the client, we will be able to participate in the optimization journey with them and deliver value for our clients. When partnering with CGG, the client immediately gets access not only to our experience and people, but also to the CGG ecosystem in general and our partners, who the client can leverage to improve their application performance and value for money.
Oh, that's great to hear for the future, and that all sounds, it could be quite exciting. And you both talk with a lot of passion about your roles. Florent, what do you enjoy most about your job here?
Everything. No, I think that we are really lucky as HPC experts to work for CGG. We are driven by the performance per dollar ratio. So any new ideas, even the ones early considered as exotic, have to be evaluated and sometimes tested. So we are not stuck with only one constructor. And also the technology for the different parts of a data center are constantly evolving. So this isn't a boring job, and we need to evolve with respect of the different industries.
And Anil, what do you enjoy most about your role?
Well, I would say similar. I guess the first is people. It's amazing the kind of people that you work with on a day-to-day basis. So talented, but so cooperative and collaborative. And even if you look at this panel, Sharon, you are in UK, and Florent is in France, and I'm in Houston. So we get to work with people around the world, similarly passionate and talented. And every time we get to work with some of the pioneers and some of the well-respected people in the industry, in the scientific form, or in the high-performance computing, it's a pleasure. And you also get the constant injection of fresh blood into the company. Very talented, young, energetic people who are passionate about technology and software development, hardware development. It's a great mix of people and a vibrant environment in CGG that you get to work with on a day-to-day basis. And an international level, that's amazing. That is really like one of the things that I enjoy most working with CGG. And the second part of what I enjoy is this co-design approach, where you really work with all aspects of an application. You are not just a pigeonholed into a specific area, so you can really see the impact whatever you are doing is making to your client, and the pleasure that you get when you are doing something good for the client and when they are happy, and then you see that the entire chain of that activities. uh, I don't know where else you get that, but that's really amazing as well. And the third part is our commitment. We try to do all of these in an environment friendly and in a sustainable way. That is really like an important part for me as well.
No, sounds great. Thank you both for joining. Have you got any ending comments that anyone wants to leave us with today?
Sure. So I guess one key thing for me is that at CGG, we are not doing academic research. It's not just for the sake of doing some research. We are trying to solve real world challenges at an industrial scale. And to do that in a sustainable way, optimizing everything that we do along the way, algorithm, all the way up to the data center facility that we have. So innovations, production environment, people, these are really like key and important things for us.
Oh, that's great. Thank you. And thank you both so much for joining me today, just sharing about your roles, the technology that you work with, how you go about your day-to-day work. Hopefully it's been insightful for those that have been watching as well. Thank you to everyone who's joined the live stream today, or if you're watching this as a recording. If you've got some questions for us, then feel free to reach out to us individually, and keep an eye out for the next episode after the summer, where we'll be building up to supercomputing in Denver. Thanks, Anil. Thanks, Florent, again.
Thank you.
Thank you, Sharon. Thanks for having me.